Hello, gentlemen. We're going to work on proving triangles similar by the AA postulate, in this case, just by AA, which we'll see what that is and what we've already talked about in class. The two main ideas to jot down as part of the notes here is to look at angle angle postulate, which is, again, something where you put on our postulate page, and also look at indirect measurement, which, if you remember from our introductory activity, it's very similar to the lake in Utah, the Salt Lake, the Great Salt Lake, where we looked at the distance between Badger Island and the bottom of Antelope Island. So let's get started. So again, if you need to pause it, go ahead and put that, do so now and look at those two main ideas. Okay. So recall, again, you don't have to write any of this down because it's something already in your notes. So looking at postulate 22, again, the angle angle similarity postulate. If two angles of one triangle are congruent to two angles of another, then the two triangles are similar. So in other words, if we look at these two congruences, we'll say these are congruent, and then we'll say these are congruent. If we look at those, we can say, oh, okay, two angles are congruent, automatically they're similar, meaning that you know that this side here and this side right here have a relationship in terms of a proportion, like the scale factor, but we can't say they're congruent. So that's what's different about these postulates talking about similarity. Not congruent, similarity, not congruent, something very important to note. Okay, so now for after this is part of the notes. This is actually all the notes for this specific section. Okay, so the first example, you want to pause it and put those visuals down, but before you do so, you might want to look at what the example said. So example one, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Explain your reasoning is going to be very brief, and there's actually not all that much work here. So I mean, I guess you have to ask yourself, what are we looking for? Like, I know we're looking for similarity, but what does the visual provide for us that we can utilize? So in this case, we have two very important things to note. Here's one of them, okay? One of them that are 90 degrees, so we can say that, it's not imperative to write this, but we're going to do so. ZYX is congruent to the measure of angle CBA. That's a B, I'm sorry. Okay, so that's one thing to note. That's number one. And then because of that, we're looking for the second one. We're looking for some type of angle congruence. That's the next piece. Well, before we do that, let's look at the two unknowns. So we could say the measure of angle CAB is something, and then the measure of angle XZY is something. Well, those somethings we can deter. If you look at this piece right here, we're going to use that. We know that this is 90, this is 37. 90 minus 37 is going to give us our 53. And we don't really need to go on further, but we're going to go ahead and finish it just to make sure we have it. But in this case, we can then see that 90 minus the 53, I'm sorry, right here is going to give us our 37 that we need. Okay, so we can then write in here 37, and we can write in here 53. Well, without doing this step, this right here gave it away for us, because if we know that these two are congruent, show congruence, then we have two sets of angles that are congruent, aka proving that the triangles are similar. So in this case, we'll put thus triangle ABC is similar to triangle XYZ, and check. Okay, again, anytime you need to pause, go ahead and pause the video and jot down what you need, and then we'll move on from there. Okay, example 2, which will pop up in a second. Show the two triangles are similar. Okay, so this one seems like it's very easy, and it is. But the big thing to note, number one, is what's automatically given to us, is to say, well, before we even do number one, we can look at these as many different ways, but it says show that two triangles. So they're saying, oh, there might be more than two. Well, if you look at it, there really isn't only two. You can just say those two in multiple different ways. We'll talk about that. So the first one, though, we want to say that the measure of angle ACB is congruent to the measure. Well, I guess we don't need to use this measure notation, but that's okay. Measure of angle DEC. Okay, so we can see 1, 2 congruent. So without even knowing any other angle measures, we can come up with the second piece of this, which is the rest of it that we need. We need to show that either this and this, or this, one of those three angles have some type of relationship to each other. Well, if D, B, and E, that's one angle, and then A, B, and C is another one, we could see that this right here, this angle, is shared by both of them. So we could say the second one, we can put it down a lot of different ways. So if we look at the measure of angle DBE, that's equal to the measure of angle ABC, and that's technically, we're going to put a little note, that's by the transitive property. Or we can even make another note and just put reflexive as well, because that might be something we'll debate about which one it is. Transitive because it's common between the two of them, and it's something they share, but reflexive because it's within the same thing. And I think we're leaning more towards on the reflexive side. We'll have a little debate about that, so we're leaving it ambiguous for now. So anyway, this one right here is congruent. You can't really see that now. I've circled it so many times. Let me actually see if I can erase that. Get rid of all this jazz. Okay. Get back to my pen. We can show that this is congruent to each other. Therefore, say thus, triangle DBE is similar to triangle ABC. Check. Perfect. Okay. Last example before that, let's make a quick note. So a big statement here. So we want to recall we used congruent triangles in blank to find angle measurements. I should say yes. Nice. There was that real long acronym that's kind of annoying. Congruent parts, CP, CT, C. I'm going to put the T first. Congruent parts of congruent triangles are congruent. Long way to say it. This little guy will help you out. So write that whole phrase, but make sure you import that. That's a C, not a K. CP, CT, C to find measurements. So now we use AA similarity postulate in proportions. We can also find measurements specifically of side lengths. So in other words, that's just saying that this postulate, as well as what we talk about with proportions, can also find measurements, which just like the CPCT does, but it's not necessarily they're congruent initially. It's that we can use a proportion to find it. Okay, a lot of rambling there. So let's just get working with it. So here's the example. And again, this is, if you want me to put it, it's still part B. So example 3, a school building casts a shadow that is 26 feet long. Same time, a student standing nearby who is 72 inches tall casts a shadow that is 48 inches long. How tall is the building? Okay, first thing is these two numbers are important. This is in feet. These are in inches, right? So let's change those to feet. So let's say 72 divided by 12, which is how many inches are in a foot. That gives us 6 feet. And then down here, 48 divided by 12 is going to be 4 feet. So those are what we're going to use instead, these two, rather than 72 and 48. So let's draw a little picture of a school. Great picture, huh? School. And let's say there's a shadow that goes out to here. This is 26 feet. Okay, 26 feet for the shadow. And we're saying that this right here is the hypothetical height of the building. Up here, something up here is going to give us that. So there's our triangle that's formed, and this is what we'll say. Let's just put how tall is the building. We'll just say that right there is X. Oops, X. So if I make that X, that'll make a little more sense. Okay, so then there's a person standing in there from about, it'd be exact if we were looking at the picture, but there's the 6 foot tall person, which obviously you can see that's a little bit too big. That's okay. And here's their 4 foot shadow. So if you think about it, here is one triangle. Oops, that's not too good. Here's another one. This is 6 and 4, and this is 26, and this is unknown. Now, using, there's 2 triangles in the triangle, but if you redraw them, this is going to also be one thing we got to add, a 90-degree angle, that this one is hopefully going to be proportional to this one because it's in the same triangle, has 90 degrees in common, and this angle right here is in common, right, because it's that vertex. So with them sharing 2 angles, they're going to be similar. So we could set up a proportion saying 6/4 equals X over 26. Okay, so we know if we cross multiply, right, little arrows at the end, so you're multiplying. This is going to be 26 times 6, which is 156, which is equal to 4x. From there, we know we should divide by 4. I'm drawing an arrow over here. X is then, if you punch in the calculator, which I've already done, 39 feet. So that's 39 feet is right there. So this school is 39, that's awful, 3, I'm sorry, feet tall. Okay, so that's what we're looking for. Using a proportion to come with that angle measurement. We're going to look at more of this tomorrow in class. But in addition to that, I want to make sure that you know there's no homework, because I obviously didn't post any on the video or on Edline, whatever the case. We'll practice it in class, but make sure you go over the topics so when you take that in-class quiz, you're not completely lost. Okay? Awesome. Have a great rest of your night. We'll talk to you tomorrow.